So, hi everyone, welcome to my channel. Today I learned about Knapsack dynamic programming, and this can also be called as 01 dynamic programming because this type of DB is all about deciding whether to choose an item or not. So with each item we can either it can either be taken or not taken. So let's go to the problem one. I will put the document link in the description below. Inside you will find the problem link, so feel free to try it out. Problem one is about bookshop. Let I summarize it. So you in the bookshop with and different book, and with each book you have a price. I call it price I, and a number of page. I call it page I, and you have a budget X. This meaning the total price of book you can buy can be at most X, and you can buy each book at most once. And the goal of this problem is to maximize the total number of pages you can buy without exceeding your budget. So the way I solve this problem, I think it's quite simple. So I have a formula dbig. This is the max number of pages you can have with first I items and the budget G. And with each item I, when we cannot choose this item, it's when G is less than price E, the item we are considering. So the dbig equal dbi minus 1G, because in the same amount of money we can always get number of base we can get from I minus 1 first item in first first item. So in the other side, if we can choose this item, when we can choose this item is when G more or equal price I. So I want to compare to know whether it is better to choose item I or just keep the old one. So in here dbig equal max dbi minus 1 G, and dbi minus 1 G minus price E, and plus base E and base I. So let's go to the problem 2. This one is about money sums. So I will summarize it. There are n elements. Each element have value ai. First print the integer k, the number of distinct sum. After this, print all possible sums in increasing order. So about the solution here, you can see there are two ways to make the current sum. The first one, with the I element you are considering, if you can make a previous sum satisfying previous sum plus ai equal current sum, so you can automatically make the current sum. So the check that's by using dbi sum equal dbi minus 1 sum. And in the second scene, if you can make a current sum by first I element, that means you can always make that sum in with first I plus 1 element. So dbi current sum equal, you can check by using dbi current sum equal dbi minus 1 previous sum. Previous sum here is equal current sum minus ai. So the last problem today is two set. So you have to summarize this one by yourself because it's so long. So I will talk about my solution. Because you have to use all elements. This means all elements from 1 to n. So this means the sum of two subsets is always equal sum of first and element and number. So we can call sum of first and number equal and multiple and plus 1 divided by 2. So each subset have a value and multiple and plus 1 divided by 4. So the result of this one is not an integer, so it's impossible. And if the result of this one is an integer, so we let call y equal n multiple n plus 1 divided by 4. So your mission here is you have to find number of ways to create y. So right here you may see this problem is quite similar to the previous one, but there are little differences. Because in the previous one here, we just want to check. You just want to check it is possible to make that k to make that. But in here you have to count the number of way we have to do that. So let the dbig is the number of way we can create the value g with first element, and you realize that if you can create value g with first I minus 1 first element, this means you can always create this value with first I element. So dbig plus dbi minus 1g. And in the next step, if there are some way to create g minus I with first I minus 1 element, this means dbig here can plus dbi minus 1g plus dbi minus 1g minus I. So the answer is db and y. Y here is this one, and because y here is just a half of sum, so half of sum of first and element. And here is the code. You can see it to know more. But in the last sentence here, there is a little knowledge of modular arithmetic. So in arithmetic, you cannot divide a number directly. So you can use multiple directly. You can see here, but you can divide directly. Because of that, we have to transform a little bit. You can see the way I transform it here. Yeah, in here I want to find a value h that and yeah, you can see the way I find out y h equals this number. And at the end, there are a few experience I can there are some takeaway I can have here. First of all, when do Knapsack dynamic programming with each element, we should consider whether we can choose that element or not, when we can choose that, and why we should choose it. And what if we cannot choose it? In our problem above, we always realize that if we cannot choose element, dbig equal dbi minus 1g. So the second experience is there is a sub problem I think will be useful in the future. Though this sub problem is there are n elements and the number k. Check if the first math is check if it's possible to use element to grid k, and the sub problem 2 is count the way to grid k. And the first one is knowledge about divide in modular. Yeah, you can see it here. Yeah, so that is all the thing I learned today, and I hope it can useful to you by somehow. See you in next video. Bye.